On July 18th, 2026, something happened that most people on Earth never even noticed. At the exact same time, one part of our planet touched one of the coldest temperatures ever recorded, while the other side was locked in one of the hottest months humanity has ever measured. Two opposite extremes happening on the same planet at the same time. If you stay with me for the next few minutes, you will understand exactly why this happened, what it means for the future, and why scientists are calling this one of the strangest climate signals in years. And if you find this as fascinating as I do, hit that subscribe button right now, because this channel breaks down real events like this every single week, backed by real data, not guesses. This is not a small story buried in some scientific journal that nobody reads. This is a fully documented, station-verified event, confirmed by researchers from France, Italy, Russia, and the United States, all measuring different parts of the same planet during the exact same window of time. And once you see the full picture, you will understand why so many climate scientists are calling this one of the clearest real-world examples of what a warming, more volatile planet actually looks like on the ground. Let's start at the bottom of the world, Antarctica. Specifically, a place called Concordia Station sitting on the East Antarctic Plateau, over 10,000 feet above sea level. This is one of the most isolated research stations on the planet. It is run jointly by France and Italy. During the winter months, no plane can land there. No plane can even reach it. The nearest human beings are at Vostok Station, which is about 370 miles away. For 4 straight months, the small crew living at Concordia does not see the sun at all. Scientists nickname this place White Mars because the conditions are so extreme and so isolated that space agencies actually use it to study how astronauts might cope with long missions to the moon or Mars. The European Space Agency even sends a doctor to live with the winter crew every year, just to monitor their sleep, their mental health, and how their bodies react to total isolation and total darkness. On July 18, 2026, the temperature outside Concordia Station dropped to minus 84.1 degrees Celsius. In Fahrenheit, that is minus 119.4 degrees. The station recorded this exact temperature twice that morning, once at 6:25 a.m. and again at 6:34 a.m. local time. This was the coldest temperature recorded anywhere on planet Earth since the year 2012. Think about that. For 14 years, nowhere on the entire surface of this planet got that cold, until this one morning in July 2026. And here is something even more surprising. This reading came within just half a degree Celsius of Concordia's all-time record low, which stands at minus 84.7 degrees Celsius. To put this number in perspective, Concordia's coldest reading ever recorded happened back in 2010, when the temperature there dropped to minus 84.4 degrees Celsius, according to some records, while other station logs list Concordia's absolute record at minus 84.7 degrees Celsius. Either way, this July 18th reading landed right at the edge of the station's entire history. And remember, the people stationed at Concordia are not strangers to brutal cold. Researchers there regularly deal with temperatures as low as minus 80 degrees Celsius during a normal winter. So when their own station leader describes a reading as remarkable, that tells you exactly how extreme this particular morning really was. Now, this was not just one isolated cold spot. The entire Antarctic plateau was going through an extreme cold spell at the same time. Automatic weather stations across the continent recorded incredible numbers. A station called Henry recorded minus 72 degrees Celsius. Another called Nico recorded minus 75 degrees Celsius. A station called Dome C2, close to Concordia, recorded minus 81 degrees Celsius. Even the famous Amundsen-Scott South Pole Station, which sits right at the geographic South Pole, recorded a maximum temperature of only minus 70.8 degrees Celsius on July 17th. And the next day, its high only reached minus 71 degrees Celsius. Its low that day was minus 76.2 degrees Celsius, which actually broke the South Pole's daily cold record for July 18th, a record that had stood since 2006. This made it the coldest multi-day stretch at the South Pole since August of 2019. At Vostok Station, the Russian research base famous for holding the coldest temperature ever recorded on Earth, back in 1983 at minus 89.2 degrees Celsius, scientists confirmed that July 2026 averaged minus 71.6 degrees Celsius for the entire month. That is 6.2 degrees Celsius below the average for the previous 2 decades, making it the coldest July at Vostok in 10 years. Out of all the Julys recorded at Vostok since 1958, only 4 were ever colder than this one. Those 4 colder Julys were 1983, when the average hit minus 73.8 degrees Celsius, 1997, at minus 72.9 degrees Celsius, 1979, at minus 72.3 degrees Celsius, and 2016 at minus 71.8 degrees Celsius. It is worth remembering that Vostok is the same station that recorded Earth's coldest ever temperature, minus 89.2 degrees Celsius, on July 21st, 1983. That single record has stood for more than 4 decades. Nothing recorded in 2026, including the Concordia reading, came close to breaking it. But the fact that July 2026 still ranks among the 5 coldest Julys in Vostok's 68-year history shows just how deep this particular cold spell really went. Even the South Pole itself, at Amundsen Scott Station, posted a July average of minus 64.3 degrees Celsius, which is 4.1 degrees Celsius below its normal range. That figure actually matched the South Pole's former July and stood untouched for 32 years, until it was broken in 1997 with an average of minus 66 degrees Celsius. The current all-time July record at the South Pole, minus 67.3 degrees Celsius, was set in 2004 and remains unbroken to this day. Now, let's talk about why this matters and why it is genuinely surprising to scientists. Antarctica is naturally one of the coldest places on Earth because of 3 things: its extremely high elevation, the fact that it sits in complete polar night during winter with no sunlight at all, and the extremely dry atmosphere, which means almost no moisture to hold on to any heat. So extreme cold there is expected to some degree, but a reading this close to an all-time record, spreading across so many different stations at the same time, caught scientists off guard. Gabriele Carugati, the station leader at Concordia for Italy's National Antarctic Research Program, spoke to Live Science about this event. He said that even in a place where extreme cold is completely normal, temperatures below minus 84 degrees Celsius are still remarkable, and they highlight just how unpredictable Antarctic weather can still be. Now here is where this story becomes genuinely strange. While Antarctica was breaking cold records, the rest of the planet was doing the exact opposite. July 2026 tied with July 2024 as the hottest month ever recorded on planet Earth, since global record keeping began in 1850. Not the hottest July, the hottest month, period. Record high temperatures were recorded across Western Europe, across the central and eastern tropical Pacific Ocean, across Central America, and across large parts of North America, South America, Africa, and Asia. The hottest temperature recorded anywhere in the northern hemisphere that month was 52.7 degrees Celsius, which is 126.9 degrees Fahrenheit, recorded in a town called Omidyei in Iran on July 14th. Just 5 days before Concordia hit its record low, on July 13th, a small community in northern Ontario, Canada, called Armstrong, reached 40.8 degrees Celsius, or 105.4 degrees Fahrenheit. That is an extraordinary temperature for a place that far north in Canada. Death Valley, in the United States, reached 121 degrees Fahrenheit that same month. Global ocean surface temperatures were the warmest ever recorded for the month of July. Global land temperatures came in as the 3rd warmest on record. North America, Africa, and Asia all experienced their warmest July ever recorded. South America had its 6th warmest July. Europe had its 7th warmest. To give you some historical context, the hottest temperature ever officially recorded anywhere on Earth is still 134 degrees Fahrenheit, measured at Death Valley, California, all the way back on July 10th, 1913, according to the National Centers for Environmental Information. That record is now more than a century old. But what makes 2026 so notable is not a single all-time record. It is the sheer consistency of extreme heat across so many regions at once, combined with ocean temperatures that stayed unusually high through the entire month. And the human cost of this heat was severe. According to a review of preliminary data by Reuters, Europe recorded around 10,000 excess deaths during a late June heat wave that rolled straight into July, with most of those deaths among people aged 65 and older. The full final number, and exactly how many of those deaths were directly caused by the heat itself, will likely take much longer to confirm. So now picture this. On one side of the planet, in Iran, the temperature hit 52.7 degrees Celsius. On the other side of the planet, in Antarctica, the temperature dropped to minus 84.1 degrees Celsius. That is a difference of 136.8 degrees Celsius, or about 246.2 degrees Fahrenheit, on the very same planet in the very same month. This contrast was first highlighted by the Weather Network, and it is large enough that, for a moment, it makes Earth feel like 2 completely different worlds happening at once. But here's the important part, the part that separates real science from social media panic. This contrast between record heat and record cold is not proof against climate change. It is not evidence that global warming is fake or paused. In fact, it fits directly into what climate scientists have been explaining for years. As the planet's average temperature rises, weather does not just get warmer everywhere in a simple, even way. It gets more volatile, more extreme. Heat waves get more intense and last longer in some regions, while shifts in atmospheric circulation, ocean currents, and polar wind patterns can trigger unusually deep, cold pockets in specific places, especially over the high interior of Antarctica at the exact same time. In 2026, Earth's average temperature is estimated to be somewhere between 1.45 and 1.47 degrees Celsius, warmer than the pre-industrial baseline, which is the average temperature recorded between 1850 and 1900. Scientists widely agree that this long-term warming trend is the single biggest factor driving the persistent, dangerous heat waves the Northern Hemisphere experienced this summer. Because of this trend, 2026 is expected to finish as the second warmest year ever recorded, behind only 2024. There is also another factor layered on top of the long-term warming trend, and that is a natural climate pattern called El Nino. Earth entered a fresh El Nino phase in 2026, which is the warm phase of a multi-year natural cycle in the Pacific Ocean that tends to push global temperatures even higher on top of whatever the background warming trend already is. Forecasters at Colorado State University, tracking this pattern, actually reduced their forecast for the 2026 Atlantic hurricane season because of it, now calling for a below normal season of 9 named storms, 4 hurricanes, and just 1 major hurricane, largely because the strengthening El Nino increases upper-level wind shear, which makes it harder for hurricanes to form and strengthen in the Atlantic. But that same El Nino pattern is also part of the reason forecasters now believe 2027 has a high likelihood of becoming the warmest year ever recorded, even warmer than 2024 and 2026. Now, let's go to the actual top of the world, the Arctic, because this is where the story gets even more layered. According to the National Snow and Ice Data Center, Arctic sea ice extent during July 2026 was the 6th lowest recorded in the entire 48-year satellite record. The Arctic overall experienced its 3rd warmest July on record. And here's a detail that really shows the long-term trend. The 10 warmest Julys ever recorded in the Arctic have all happened since 2012, not spread out over decades, all within the last 14 years. From mid-June through mid-July 2026, Arctic sea ice extent was actually tracking close to the levels seen back in 2012, the year that went on to set the record for the lowest Arctic sea ice extent ever measured by satellites. But at the exact same time, something unusual was happening in a very specific part of the Arctic. Weather data from the Danish Meteorological Institute, tracking the region above 80 degrees north latitude, what scientists call the high Arctic, showed a remarkable stretch of unusually cold daily temperatures throughout the summer of 2026. Out of 41 days, from July 1st through August 10th, 36 of those days set a new record low daily mean temperature for that specific calendar date, compared to every single year going back to 1958. That is 88% of the days in that stretch setting a cold record. There was a run of 20 straight record cold days from July 2nd through July 21st, followed shortly after by another 12-day record streak from July 23rd through August 3rd. On July 26th, the average temperature for that day across the whole high Arctic dataset was the coldest July daily mean ever recorded in that entire historical archive. And then on August 9th, the reading came in even lower, becoming the coldest daily summer mean across the entire 68-year record for that time of year window. So here is the full picture. The wider Arctic, as a whole region, including its ocean, its sea ice, and its overall July average, is warming fast, with sea ice shrinking toward historic lows, and July temperatures ranking among the warmest ever measured. But a specific narrow band right at the very top of the Arctic, above 80 degrees north, experienced one of its coldest, most persistent summer cold streaks ever documented in the same window of time. 2 data sets, 2 different scales, 2 different signals from the same region happening simultaneously. This is exactly the kind of complexity that makes modern climate science so difficult to summarize in one simple sentence, and exactly why real scientists are cautious about jumping to easy conclusions from any single station or any single month. It also helps to understand exactly why Arctic sea ice matters so much in the first place. Sea ice acts like a giant reflective shield for the planet. Bright white ice bounces most of the sun's energy straight back into space. But when that ice melts and turns into open, dark ocean water, the ocean absorbs far more of that heat instead of reflecting it. Scientists call this feedback loop the ice albedo effect, and it is one of the biggest reasons the Arctic as a whole region is warming several times. Faster than the global average, even in years, or in specific pockets of the Arctic, where individual weather stations post unusually cold daily readings. A cold week at one station 80 degrees north does not cancel out a 48-year decline in the total amount of ice covering the Arctic Ocean each summer. Both things are simply measuring different parts of an extremely large and complex system. Meanwhile, this extreme cold in Antarctica did not stay contained to the continent itself. The cold air mass that caused Concordia's record actually pushed outward and affected the wider southern hemisphere. Russia broke at least 9 separate low-temperature records between July 17th and July 19th, as unusually cold air spread across the country during what should have been the middle of its own summer season. an outbreak of Antarctic. Origin cold air brought rare low-level snowfall to New Zealand, and this outbreak later intensified, breaking all-time temperature records across New Zealand's North Island. Southern Chile also dropped below minus 20 degrees Celsius during the same period. Before we go further, let's also address something you might already be thinking. Is this the first time something like this has ever happened? Not exactly, but it is rare for the numbers to line up this cleanly within the very same short window of time. Weather records get broken somewhere on Earth almost every single week now because we have detailed instrument records going back well over a century and thousands of monitoring stations spread across the globe today. What makes the July 2026 event stand out is not that a record was broken. It's that one of the most extreme cold readings in over a decade, and one of the most extreme collective heat months ever measured, happened during the very same 31-day stretch, on opposite sides of the same planet. That kind of alignment, backed by verified station data from multiple independent research programs, French, Italian, Russian, American, and Danish, is what turns this from a routine weather story into something genuinely worth stopping and studying. It also helps to remember that Antarctica itself has produced both extremes in recent years, not just cold ones. Back in March 2022, the Concordia base recorded an extraordinary temperature spike, hitting minus 11.5 degrees Celsius, which is more than 30 degrees Celsius above normal for that time of year. On the same day, another station called Dumont d'Urville recorded 4.9 degrees Celsius, an almost unheard of reading for coastal Antarctica in what should have been its early autumn season. So the same continent that produced one of the coldest readings on Earth in July 2026 had, less than 4 years earlier, produced one of the most extreme heat spikes ever documented on the entire continent. This is exactly the kind of whiplash that scientists mean when they describe Antarctica's climate as becoming more variable over time, capable of swinging toward extraordinary heat or extraordinary cold, sometimes within the very same decade, sometimes at the very same research station. Now, let's step back and ask the bigger question. Why does this keep happening? Why does a warming planet sometimes produce these dramatic opposite extremes at the very same time? Climate scientists point to a few connected mechanisms. First, atmospheric blocking patterns. These are large, slow-moving areas of high pressure that can get stuck in place for days or weeks, trapping heat under them in one region while allowing cold air to pool and intensify somewhere else. Second, changes in the the strengthened shape of the polar vortex, the massive rotating pattern of cold air that normally stays locked over the poles. When the polar vortex weakens or shifts, it can allow pockets of extremely cold air to build up in unusual places or to spill out toward lower latitudes. Third, the unique geography of East Antarctica itself. Concordia sits on a plateau over 3,000 meters high, on top of more than 3 kilometers of solid ice, hundreds of miles from the nearest coastline. That extreme elevation, combined with total winter darkness and an incredibly dry atmosphere, creates the perfect natural conditions for temperatures to plunge to depths that are almost impossible anywhere else on the planet, whenever the right atmospheric setup lines up. Johann Rockström, director of the Potsdam Institute for Climate Impact Research in Germany, spoke to the New York Times about the pattern of extremes the world experienced through 2026. He said that this year should be seen as just the beginning, and that conditions will keep getting more difficult until humanity starts approaching the real limits of what people and ecosystems can adapt to. This is exactly why individual events like the Concordia cold record are studied so carefully by climate scientists, rather than being dismissed or oversimplified. A team of researchers, publishing in the journal Advances in Atmospheric Sciences, studied a separate but similar cold outbreak in Antarctica that happened during the winter of 2023, a year that was, at the very same time, breaking global heat records almost everywhere else on the planet. That study identified 4 distinct cold phases across Antarctica between mid-July and the end of August, and it traced the cause back to specific atmospheric patterns high in the atmosphere, at around 18,000 feet. Combined with unusually calm, still air sitting directly over the continent. During that same 2023 event, flight operations to major Antarctic research stations had to be suspended entirely because the cold became too extreme and too dangerous for aircraft to safely operate. It's also worth understanding what these extremes actually mean for the people and wildlife living through them, not just for the record books. At Concordia Station, the small winter crew, sometimes as few as a dozen people, sometimes up to 16, are trained specifically to handle conditions like this. Their equipment, their clothing, their entire daily routine is built around the assumption that temperatures this extreme will happen every single winter. For them, minus 84 degrees Celsius is dangerous, but it is not unfamiliar. The bigger risk during events like this is usually mechanical. Fuel can thicken, metal can become brittle, and even simple outdoor tasks have to be carefully timed and limited to short windows. because exposed. Skin can suffer frostbite within minutes at those temperatures. Meanwhile, thousands of miles north, the heat waves rolling across Europe, Iran, and North America create a completely different kind of danger, one that disproportionately affects elderly people, people with existing health conditions, and people without reliable access to air conditioning or cooling centers, which is part of why the excess death toll in Europe climbed so high during the late June and July heat wave. This is also why scientists keep drilling deep into Antarctic ice itself, not just watching the daily weather readings. Ice cores pulled from more than 1.5 miles below the surface have allowed researchers to reconstruct roughly 1.2 million years of Earth's climate history, layer by layer, year by year, frozen in place. That deep historical record is what allows scientists today to say with confidence that the current pace of global warming and the current pace of ice loss happening in places like Greenland and West Antarctica is unusual compared to natural, slow climate shifts that unfolded over many thousands of years in the past. Separately, researchers have also been tracking warm ocean water that used to stay trapped deep within the Southern Ocean, far from the Antarctic coastline. In recent years, that warm water has been encroaching closer to the Antarctic ice shelves themselves, which is a completely different threat than the atmospheric cold snap that hit Concordia, but one that scientists are watching just as closely because it directly affects how fast coastal ice shelves melt from below. So when you connect all of this together, here is the real, complete picture of what happened at both ends of the planet in the summer of 2026. Antarctica, driven by its extreme elevation, total winter darkness, and a specific temporary atmospheric setup, plunged to its coldest reading in 14 years, with the cold spreading across the South Pole, Vostok, and multiple other stations at once. At the very same time, the rest of the planet, especially the northern hemisphere, endured one of the hottest months ever recorded, with deadly heat waves across Europe, extreme highs across Iran and North America, and the second warmest year on record now well underway. And layered on top of all of that, the Arctic showed two contradicting signals simultaneously, an overall region trending toward historically low sea ice and near record warmth, while a narrow band at its very top experienced one of the most persistent summer cold streaks ever measured in that specific data series. None of this happened by pure coincidence, and none of it is unprecedented in terms of cause. What is unusual is how sharply these opposite extremes lined up in time, and how large the gap became between the hottest and coldest points on Earth within the very same month. A temperature swing of nearly 137 degrees Celsius across one planet in 1 month is the kind of number that forces scientists, and now you, to pay close attention. Scientists are continuing to monitor this pattern closely, because events like these help build long-term forecasts and improve climate models for years into the future. Every single extreme reading, whether it's a record high in Iran or a record low at Concordia Station, gets logged, cross-checked, and fed into the larger data set that researchers use to understand how our planet's climate system actually behaves as it continues to change. So what should you actually take away from all of this? A few things. First, a record cold reading in one specific place does not cancel out a warming planet in the same way that one hot day in your city does not prove climate change on its own. Climate scientists look at long-term averages across decades and across the entire globe, not single readings from single stations. Second, the polar regions, both the Arctic and Antarctica, are becoming more volatile, not just warmer, or colder in a simple straight line. That volatility, more intense heat waves in some regions, deeper cold snaps in others, sometimes within the very same month, is itself one of the clearest signals that our climate system is shifting away from the more stable patterns it followed for most of the last century. Third, the tools we have to track all of this, satellites, automatic weather stations, ice cores, ocean buoys, have never been more advanced or more precise than they are right now, which means events like the Concordia cold record and the July 2026 heat extremes are being documented and cross-checked in real time by multiple independent teams in multiple countries using standardized methods. That is exactly why we can trust these specific numbers, even while the bigger picture of what is causing them continues to be studied and refined. Researchers will keep watching Antarctica's interior through the rest of this winter season, watching to see whether more record-breaking cold readings show up before the sun eventually returns to Concordia Station later this year. At the same time, climate agencies around the world are already looking ahead toward 2027, watching how the current El Niño pattern develops, because if forecasters are right, next year could end up breaking the all-time global heat record currently held by 2024. Every one of these readings, whether it is a new low at the bottom of the world or a new high somewhere near the equator, adds one more data point to one of the largest, most carefully verified scientific records humanity has ever built. If this kind of real, data-driven breakdown is something you want more of, make sure you are subscribed to this channel because we cover stories exactly like this one every single week. always backed by real numbers from real scientific sources, never guesswork, never exaggeration. Drop a comment and let me know, were you surprised that Earth's hottest and coldest points happened in the very same month? Or does this actually make sense to you now that you understand the science behind it? Like this video, if you learned something new today, share it with someone who still thinks a cold day somewhere disproves a warming planet. And I will see you in the next one.